All right. Hey, today's lesson notes presentation is going to focus on one particular ecosystem that we find, especially in southeast Minnesota, and that is the riparian ecosystem. Okay. Riparian ecosystem, maybe it's a term that we aren't as familiar with, but we're talking about, in particularly, small rivers and streams and their floodplains. So that is I know in northern and in central Minnesota, we have a lot of lake country where there's these big pockets and pools of water. In the southeast side of the state, it gives way due to the limestone nature of the geology in the area to streams and rivers. And it's actually a pretty unique ecosystem in how we can evaluate its health and those kind of things, and what we can look for to tell if um, they are well balanced ecosystems. All right, so we're going to look at a variety of factors today, look at some examples that help determine that. So, key components to healthy trout streams. We're going to talk about cold water. We're going to talk about high dissolved oxygen content. We're going to talk about gravel bottoms, large woody debris, and a healthy floodplain, as well as a pollutant-free watershed. Okay, so why should we be looking at trout specifically when we're looking at an entire, we're going to be looking at an entire ecosystem of all this, uh, the stream, the river, the land that's around it, all these things. So why on earth would we focus on just one species? Well, they're kind of convenient species for us to study. One, they are economically and entertainment value wise, an important species in a lot of areas. People are interested in catching trout, and so we can monitor their success of their population quite easily. They're also very fragile animals, right? So trout require some very specific conditions to live in. So if the stream is healthy enough for trout to live in, that means that there's a lot of other species that can do well in that particular stream. So if we focus on let's make the stream healthy enough for trout to live in, then we're also going to provide a nice and healthy ecosystem for a variety of species to live in as well. So first one, cold water. Okay, so trout thrive on cold water, and cold water is also a sign that the surrounding area is in good shape. For our region here in the Midwest, that's almost entirely spring-fed water, so it's groundwater that's coming up through cracks in the limestone or whatever the substrate is. And when I say cold, we're talking about 44 to max 65, 67 degrees year round. Okay, so in the 95-degree heat of summer, this stream's staying at 65 degrees temperature wise. It's moving, it's clear, and a big factor as to why this is important is that cold water can hold more oxygen than warm water can. That's really big. Trout require a lot of oxygen, and so cold water is better at holding that. Also, if the water is very cold, typically that means it is free of fertilizers and nitrates and those kind of things from that have washed down from the floodplain itself there. So cold water is important. Like I said, it can hold more oxygen, and so we look at dissolved oxygen in water. Now, this is a measurement that might not mean a lot to a lot of us, but they're looking at more than 5 milligrams per liter of dissolved oxygen. Remember, fish breathe air, all right? Maybe I shouldn't phrase it like that. Fish require oxygen, yet they get their oxygen from the water, not from the air. So they need a lot of oxygen in the water moving around. Things that drop dissolved oxygen would be decaying matter, so dead stuff in the water, stagnant water, so if the water's not moving, and lots of algae growth. Okay, if we see those three things in our bodies of water, we know that, hey, this isn't maybe necessarily a healthy ecosystem. Big lakes, yeah, they might have some more algae growing there, but for rivers and streams, we don't want those kind of things. The substrate or the bottom of the river or stream is important too. Here we're going to look for a gravel bottom versus a muddy bottom. What it is that's vital for reproduction. Here we're actually looking at two trout reproducing here. The one has laid a bed, and the other is probably going to deposit sperm over eggs here shortly. They need that for their to reproduce naturally in the wild. Also, if you have a rocky bottom, that's going to reduce chances for erosion. So big rainfall events aren't going to just wash out the entire bottom or sides of the stream. It's going to mean your water's clearer if you have a rocky substrate instead of a muddy substrate. And so in general, it's a nice indicator for that stream water quality there. Next up would be large woody debris. So while we don't want a bunch of dead and decaying stuff in there, it is good to have structure in our streams. Here we look at actually, this is a group of Conservation Corps workers putting in large woody debris. Here you see it being used as a force observer. So as water's rushing down this stream, it's going to slam into this riverbank, and over time, it's going to erode it. So it's going to erode that soil. That soil is going to wash down the stream, gone forever. We want to keep our soil where it's at. And so having this debris helps break up some of those forces that water can sustain, especially in different flooding events. It helps kind of absorb those things, and it also stabilizes the stream bank and provides habitat for those fish in there. So large woody debris in there. Okay, the floodplain. Now we're not talking about the stream itself. We're talking about the sides of the stream. Um, we want our streams to be meandering versus a linear path. We want gradual slopes to our banks, not steep cliffs. And we want perennial plants versus annuals. So if you look here, here's a look at a guy holding a perennial plant versus annual plants. Annuals mean we plant them, we harvest them within the same cycle. Perennials mean that they live their entire lives out there over a number of years. And if you look at the root structure on those, the perennial plants are going to hold that soil into place a lot better. Remember, erosion is bad for us. We want to try to keep our soil where it's at here in the Midwest. It's valuable. So perennial plants do a much better job of keeping it there. Here's a look at those river banks that I was talking about. So the picture on the right, that water when it floods is going to have a place to go. It's going to have a place to spread out. Yes, it's going to cover land. That's good. It's going to deposit all that silt that's washing down. It's going to take some of the force out of that main channel as the flood plains are moving, versus the one on the left. As that rises, there's no place for that water to go. It's going to keep building momentum and force. It's not going to deposit any silt. Instead, it's going to be ripping some of that soil along with it. And so we want to look for those banks on the right. And then same thing here when we talk about meandering versus linear. Here's a look at a nice brook in southeast Minnesota. If you look at its natural path, it is far from a straight line. It is following the contour of the hillside, and we've all run a sprint before, and we're much faster, and we can build up a lot more speed if we're running in just a straight path, versus if we keep constantly having to turn, we're going to naturally go slower. We want our streams going a little bit slower so that they're not just devastating the land around it when it floods. Versus if you look at on the right, we have a lot of that in the state of Iowa because of all of our agricultural needs. Many of our streams have been taken and they've been linearized. So that is not a natural path for the stream there. That has been man-made into a straight line to make it more convenient for agriculture. Okay, and then I believe lastly here we have a healthy watershed. So when I say watershed, I'm looking at not just the floodplain, but everything that potentially drains into that river. So when it rains, Some of that water is going to be absorbed into the ground. Some of it's going to run off and will eventually make its way down to a river or a stream. That's the watershed. So watersheds can be, several hundred square miles in size. And so healthy watersheds would not have a lot of chemical runoffs. Okay, some of the top pollutants there would be industrial uses, residential. So whatever you're putting on your yard to make sure that crabgrass isn't growing or that it stays green. Um, Agricultural, and then recreational. Actually, golf courses. I like playing golf, but golf courses are one of the ecologically one of the worst things for our streams there. And same thing, we want topsoil. Okay, we want topsoil that is going to stay into place. So when you see a bunch of agriculture that's constantly tilling up that topsoil and breaking it up and making it loose, that means when it rains, some of that is going to wash away over time. And so whenever we have a heavy rainfall, whatever's on that surface of those grounds is going to end up in our trout stream. That is part of the reason why it's important to have some kind of a buffer strip in your watershed. If you look at the picture on the right, clearly we can see that there's a river moving through that agricultural field that is surrounded by this buffer strip of trees and probably different sedges and grasses and those kind of things. In those big rainfall events, that buffer strip is going to help hold some of that runoff, some of that soil in that spot and keep it out of the stream. Versus our look on the left, clearly when it rains there, whatever is on the ground is going to end up in the stream itself there. So there's a look at some healthy components of trout streams. And once again, like I said, if we know that trout are thriving and doing well in our streams, we know that all of those things are probably mostly true. Okay, we know that we have a healthy ecosystem around the trout. And so, kind of a cool species that we can look at that can, if we take care of the trout, we can actually take care of a huge number of species in the area. So, that is our riparian ecosystem presentation.